Hey there, I'm Casey. I've got a bachelor's degree in radiologic science and a master's degree in health informatics. My background is in healthcare data, program evaluation, and quality control, basically making sure that what's supposed to happen in a system actually does. I'm not an expert. I'm a lifelong learner who spent years asking the hard questions and fixing messy workflows. So, if you've ever second guessed your SQL joins or wondered why your numbers feel off, you're in the right place. Let's break it down together. Change one word in your SQL join, just one, and suddenly your hospital report says 300 patients got treated last week, when it was actually 87. That's not just a mistake, it's a potential disaster. Let's go to the whiteboard, and I'll show you exactly how one to many relationships can quietly break your data. The core idea: tables are like spreadsheets with rules. Let's start with the basics. In a relational database, each table is like a spreadsheet. You've got rows of data and columns for each type of information. So we've got our patient table with 3 patients: Alice, Bob, and Charlie. This is your patient list. Each row is one patient, but in healthcare or in a real system, we're not just looking at one table. We need to connect information. So we bring in a second table. Let's say appointments. So we've got appointment ID, patient ID, and the date of the appointment: January 2nd, January 5th, and January 3rd. Now we have 2 connected pieces of data. One table tells us who, and the other tells us when. Here's where it gets interesting. How we join these 2 tables can completely change what our final data set looks like. Let me show you what I mean. So we have a patient's table and an appointment table. Each patient can have many appointments. That is a one to many relationship. Now watch what happens when we join these tables together. Let's write this SQL code. Select name from the patient table and date from the appointment table, and let's join those tables by the patient ID. Your result would look something like this. Do you see how this multiplies rows? That's what we call cardinality. It affects totals, averages, and how accurate your analysis is. Now let's add a patient detail table. Patient ID and insurance status. What if we want to pull in extra information without changing the number of rows? That's where a one-to-one relationship comes in, like patient ID and patient insurance status. This new table, let's call it patient details, has exactly 1 row per patient. We're not multiplying anything, we're just enriching the record. Let's use this select statement to grab the name from the patient table, the insurance status from the detail table, and then let's join those by the patient IDs matching. Since there's only 1 match per patient, your result stays clean: 1 row in, 1 row out. That's the magic of one-to-one relationships. The result would look something like this. This kind of join is great for bringing in demographics, insurance information, or anything else that's one-to-one. You get more detail without changing your row count. But what happens if that extra detail is missing? That's where we need to talk about the difference between inner and outer joins. So far, we've been joining tables where every match exists, but real data isn't always that clean. What happens when a patient doesn't have matching information in the second table? Let's take a look at our patient table, and then let's take another look at our appointment table. Charlie has no appointments on file. Let's see how that affects the data. Let's write this code. Let's select the name, date from the patient's table, and let's do an inner join using the patient ID. Your results would look something like this. An inner join says only give me rows where both sides match. So Charlie gets dropped completely, even though he's still a valid patient. Next up, we're going to grab the patient name, the appointment date, and we're going to do a left join appointment on patient using the patient ID. Your result would look something like this. A left join says, give me all patients, match what you can. Now we keep Charlie, and we can clearly see he has no appointment on record. This matters. A hospital admin doing an inner join might think Charlie doesn't exist. A left join shows he hasn't been scheduled yet. That's the difference between missing data and missing people. And when it comes to analysis, that one word left can change everything from your patient counts to your treatment compliance metrics. So let's talk about how this plays out when you're running aggregate queries. Let's talk about one of the easiest ways to mess up a report using a join without thinking about how it affects your aggregates. Say we want to count how many patients were seen. Seems simple, right? But depending on your join, you could get totally different numbers. Let's count the patient ID as the total seen. That means we're renaming that as a column, and that column's title is going to be total seen. We're pulling that from the patient's table and we're joining that with the appointment table using the patient ID. This counts rows after the join. Since Alice has 2 appointments, she gets counted twice. So our total seen is 3. That's not 3 patients, it's 3 appointments. The join changed what we're counting. Next, let's try grouping. We're going to use a left join. So we're going to select the patient name and we're going to count the appointment ID as a visit count. We're going to do a left join on the appointment table using the patient ID again. And we're going to group by the patient name. This is what our result would look like. Now we're getting exactly what we want, a count of appointments per patient, even showing us Charlie, who hasn't had any. This works because we're grouping before we count, and we're using a left join to keep everyone in the data set. Here's another example if we wanted to look at the average appointments per patient. Check this out. We're going to take our statement that we just did before, and then we're going to wrap it in another select statement so we can get the average. Now, take a look. We're going to select the average visit count from that, and we're going to rename that as counts. If you use an inner join here, Charlie's not in the data set, so the average is inflated. So let's fix that. This is the correct code. Same math, totally different meaning. That's why understanding your joins isn't optional, it's essential. One extra row can throw off your dashboard. One missing patient can make a report look better than it is. Joins aren't just technical, they're about truth in your data. Understanding how relationships and joins work isn't SQL trivia. It's the difference between truth and misleading data. And now you've got the whiteboard version burned into your brain. If this helped you understand joins a little better, hit that like button so more folks can find it too. And let me know in the comments, do you want more breakdowns like this? Or are you more into research-based deep dives? I read every comment, and don't forget to subscribe.